Okay, so so I'm going to show you a little bit like where the parallel node sort of has its. It's really exciting to have this parallel node, but it actually has its shortcomings, uh, and uh, and I'll show you a sort of a solution that is possible to implement in this software. So one of the things that we often want to do when we want to run things in parallel is that we want to have like sort of we want to have sort of um, a main program that's running, and while it's running we want to do other things on the side. Okay, like for example we want to have our main program running and changing some values and this, but at the same time we want to keep listening to new incoming OSC messages. Okay, so let's see how we can intuitively come up with that using a parallel node. And what we'll do actually sort of as a first little example is we're gonna change a value on the blackboard, okay, using a blackboard ramp, and then we're gonna try sending it using OSC send. Okay, so I'm gonna create this children here blackboard ramp, and I'm gonna ramp a value between called value, just call it value, between 100 and 200 in 10 seconds. Okay. Okay, so just to show you what this does, I'm gonna go control left arrow. I'll put it on the same level as the parallel node, and I'm just gonna disable this parallel node. So this way, like, we'll preserve this, but this blackboard ramp is just gonna be there, and I'm gonna run this. So you'll see now that this value called value goes from 100 to 200 in the space of 10 seconds. Okay. Back to normal. Control right arrow puts it back under parallel. I'm just going to re-enable the parallel node. And I'm going to add a children, okay, called OSC send. I'm going to send the value. Let's say I'm going to call it bb/val, whatever is the path I chose, and I'm going to send value to bb/val. And here I'm going to listen to whatever incoming message comes. And let's run it. So what's happening? So you see that it's not, doesn't really do what I intended to do. Okay? I'm just going to stop this. So it just, you see that it just sent one value of worth 100. Why is that? That's because the parallel node, what it does, again, once again, what it does is it just executes all of its children. Okay, only once. It just executes them once until until one of them fails or all of them succeed. So what it did is that, well, it did both of them at the same time, but then OSC sent its message and succeeded. You know, when OSC send, unless there's an error, it's just going to succeed, and then yeah, it doesn't repeat itself. And so let's say, for example, that another thing that I would like to do is receive some value at the same time. Let's say I'll receive something on B. I'm gonna wait for something called sensor, and I'm gonna send it to the variable sensor. Okay, and let's say that here what I want to do is, here in the OSC send, I actually want to send value times sensor. Okay, so what happens here? Oh, what just happened? Okay, what just happened here? What just happened actually is that it's not very clear, but this thing value times sensor won't work because sensor needs to be initialized. Okay, so I'm just gonna set blackboard set. I'm just gonna give a starting value, a default value, and I'm just gonna set it at the beginning. Okay, so this way, you know, there's already a value for sensor. What happened with OSC send? Well, I got 0, right? because the sensor is set to sensor value is set to 0. Now just gonna do something here. I'm gonna send to port which one is it? 14,000. I'm gonna send to port 14,000. I'm gonna send a sensor value of 1. Okay. So just send it, and okay. So I'm just gonna restart from the beginning. Okay. So you got here. This is what got dumped, 0, and I send value 1 to sensor, and our sensor is set or is worth 1. But did this react at any point when I send the sensor value to 1? No, it just didn't react, because once again, OSC send. I'm just going to repeat it once again. Okay, OSC send did its action at the beginning. It succeeded. If I wait until the end of, like, now Blackboard ramp has succeeded, well, OSC receive is still waiting for some message to happen, and as soon as it receives it, the parallel node will succeed. So this is not really what we want here. What we'd want is, we'd like this Blackboard ramp, okay, to change, but as it changes, we want to keep sending messages and keep listening to new messages, okay? And we can do that using a very special kind of node called a simple parallel, okay? So this is so the simple parallel is sort of it's like a parallel, however slightly different. The simple parallel sort of works as kind of a master-slave kind of control structure. So where the first child is privileged, the first child is going to be running, is going to be running once, and the other ones, all of the other children, they're going to be run over and over and over. They're just going to be repeated. Okay. So even if they succeed, they're just repeat themselves over and over again. Okay. So that's different. So let's first have a look at the reaction of the OSC send. Okay. So what I'm going to do here, I'm just going to create just different terminals. This way we'll have here, we'll be able to send messages. Here I'm going to have my OSC dump. Okay, OSC dump on my 12,000 port. Okay, and let's see what's happening if I start running this. Okay, so what you see here is that I'm starting to get, like, this is scrolling, but I'm getting all these values. Now, as soon as I send a new value, okay, I'm just gonna increase this. It's gonna run it for a long time. Let's say for a minute, 60 seconds. Okay, so once again, just restarted it. So you see, I send, so this is running, and this OSC sends keeps repeating, keeps sending values, but it's always multiplied by the sensor value, which is 0. So if I send a new value, now this one, the OSC receive, is also constantly waiting. So now I'm starting to see those values, and since it's a multiplier, every time I send the sensor value, it's going to change, of course, the value times sensor here. Okay, so this is like, and let's see what happens. Like, so when it's going to reach its final value, then it's just going to interrupt itself. It's just going to stop and exit. Of course, if the first child fails for whatever reason, then it's the simple parallel is also going to fail. So let's see. So you see, it all nicely. So the Blackboard ramp, which was sort of the master, the first child, which is sort of deciding when all of this is stopping. It after a minute of running, it ended, and then it exited with success, and so the simple parallel succeeded.